Today we're looking at Lesson 2.5, which is on postulates, and we're beginning to look at proofs. Now, when they say paragraph proof, I'm not going to be such a stickler in terms of it being in the correct form like a paragraph. I would also accept something like a 2-column proof, but when we get to the proof problem, I'll go over that a little bit more. So the first thing I want to address your attention to, this is in the textbook on page 127, should also be in your key concepts packet, but these are the startings of what you will use to help you write proofs. So we have what's called a postulate. Sometimes you'll rarely hear it called an axiom, but basically a postulate is a statement that's already accepted as true and we don't need any proof. So they have different postulates here about points, lines, and planes, and the intersections of lines and planes. So when you're explaining something, you're going to use these postulates to help you with your proof. So the first part here has to do with the picture, right here. And we need to explain how the picture illustrates that each statement is true, and then state the postulate that can be used to show each statement is true. Okay, so if we look at the picture, and then we look at the statement, points A, B, and C determine a plane. Well, I don't know why this keeps going so fast. So look at the picture. A is here, right here, whoops. A is here, B is here, and C is here. So notice that it forms a triangle. So since it forms a shape, we can definitely say that that is true, but our explanation needs to come from the postulate list. So if we go back to the postulate list, we need to look at something about points and planes. So let's see. A plane contains at least 3 non-collinear points. I would say that probably would work. Or through any, okay, I would say 2, 2 would have to be the best one there, because through any 3 non-collinear points there is exactly one plane. Well, they give us 3 non-collinear points and they say that they determine a plane. So 2, 2 would be more so accurate than 2, 4, because 2, 4, it already is established that it's a plane, not that we're forming or determining a plane. So postulate 2, 2 would be my explanation. The next one also comes from the picture. Planes P and Q intersect in line M. So planes P and Q, plane P is going to be right here, okay, and plane Q is over here. So it's saying that they intersect in line M, and you can clearly see that line M goes down here like this, and that's where they intersect. So we know that it's true. And the postulate that we use to describe it, if we go back to our postulate list, we need to look for lines or planes intersecting, and it says postulate 2.7, if 2 planes intersect, then their intersection is a line. Well, that's exactly what our statement said. So it said planes P and Q intersect in a line. So postulate 2.7 would be my explanation. The next part, we're going to determine whether each statement is always, sometimes, or never true. And we're using a little bit of the postulates and a little bit of common sense here. But if you have 2 intersecting lines and they determine a plane, do you think that they're always going to determine a plane, sometimes, or never? I would look at the list. And if we look at lines intersecting, it says if two lines intersect, then their intersection is exactly 1 point. If two planes intersect, then their intersection is a line. Let's see, I would say postulate 2.2, because if you have intersecting lines, you're always going to have at least 3 points, but they're usually collinear on the lines. But if we draw a line and then another line that intersects, we could put a point here and a point here and a point here, and we would still have a plane because you have 3 non-collinear points. So that would be postulate 2.2. The next one, 3 lines intersect in 2 points. Well, if we have 3 lines and they're intersecting, that's at 1 point. Can we even draw 3 lines that intersect at 2 points? No, because all 3 lines are never going to be able to intersect at 2 points. It would have to be either 1 point or like 3 points. But you would say never there. So, because there's no way to have 3 lines intersect at 2 points. Okay, this is an example of the proof process, and this will be important for when we do pretty much any kind of proof. You always want to start with whatever you're given, which they call the hypothesis. Usually they're also going to give you the proof statement, but that's going to be your last step in a proof. So you list the given, okay, whatever is given to you, and then you have to tell me basically the theorems or conjectures that you need to be able to prove that the given is true, okay? So you're going to be basically listing with steps a lot of times, okay? In this case, with a paragraph proof, they're asking you to write it in sentences, but I'm not going to be as formal, okay? We're going to be more informal here, and we're going to have a 2-column. Even though paragraph proofs are considered informal, paragraphs is a lot more writing, so I'm going to have you just do a two column. So here is my given, okay? It says given that C is between A and B and AC is congruent to CB. It says write a paragraph proof, but I'm going to have you write a 2-column proof, which is basically like a T-chart. You have the statements, and the reasons. And you always start with your given. So they gave you that C is between A and B. And that is your given. That's the reason. And AC is congruent to CB. And that's also a given. Now we need to prove that C is the midpoint of AB. And that'll be our last step. Okay, so basically think of if C is between points A and B, then by definition, A, B, and C are going to be collinear. So we can say that AC plus CB equals the total, AB. Okay, so that would help us prove. Then we have AC being congruent to CB, so since they're congruent, by the definition of congruence, they have the same measure. That we didn't need to prove, though, because that was given to us. Then it says, from the definition of a midpoint, C is between points A and B, and AC and CB are congruent, then you can conclude that CB is the midpoint. So, this is going to be by definition of a midpoint. And in this case, this is not going to be a normal proof where you have two givens and then you have the proof right away. Usually you have more steps here. In this section, you'll have more than just givens and proofs. You'll have a few extra steps and then you're trying to get to the proof part. But that would be, in this case, our proof. Okay? The definition of a midpoint. And that concludes lesson 2.5.